In the vast universe, our solar system is a marvelous and stable system, where the Sun lies at the center, and the planets, including Earth, revolve around it in regular and predictable orbits. Have you ever wondered, why don't these planets get pulled straight into the Sun, a gigantic star with an incredibly strong gravitational force? Intuitively, when there is an object with such powerful gravity like the Sun, it seems like everything around it should be sucked in and disappear. Yet, for billions of years, the planets have maintained a stable distance from the Sun and continue to orbit it steadily. The answer lies not only in gravity but also involves many deep physical factors such as inertial motion, dynamic equilibrium, Kepler's laws, and the laws of conservation. Understanding this mechanism allows us to appreciate the wonder and order embedded in the vast cosmos, where each planet is dancing in harmony with the perfect laws of physics. 1. The Sun's gravitational force, the giant pull that keeps planets close. The Sun is the central star of the solar system, accounting for more than 99.8% of the system's total mass. With such an enormous mass, the Sun generates an extremely strong gravitational field that pulls all surrounding objects, including planets, asteroids, comets, and gas dust, toward it. According to the law of universal gravitation proposed by Isaac Newton, every object with mass attracts every other object with a gravitational force. This force is directly proportional to the product of the two masses and inversely proportional to the square of the distance between them. Applied to the solar system, the Sun, with its immense mass, acts like a powerful cosmic magnet, constantly pulling the planets toward it. If there were no other influencing factors, the planets would fall straight into the Sun, just as an apple falls to the ground due to Earth's gravity. However, reality tells a different story. The planets don't fall, but instead orbit the Sun along fixed paths. 2. Planetary inertia, the universe's outward push. One of the key reasons planets don't fall into the Sun is because they are in motion. They are not standing still in space. When the solar system formed from a cloud of gas and dust about 4.6 billion years ago, the materials spun around and gradually clumped together to form the Sun and the planets. From the very beginning, the planets had a certain velocity, causing them to keep moving through space. According to Newton's first law of motion, also known as the law of inertia, an object in motion will continue moving in a straight line at a constant speed unless acted upon by an external force. So, if there were no gravitational pull, the planets would continue flying off in a straight line and leave the solar system. It is the Sun's gravitational force that bends their paths into curved orbits, keeping them from drifting away, but it's not strong enough to pull them straight into the center either. 3. The balance between gravity and inertia, the perfect orbit keeper mechanism. The stable motion of planets around the Sun is the result of a perfect balance between two opposing forces, the Sun's gravitational pull and the planet's inertial motion. Gravity tends to pull the planets toward the Sun, like a string pulling a stone toward the center when you swing it in a circle. Meanwhile, the planet's inertia causes it to want to move in a straight line away from the Sun, out of its orbit. When these two forces reach a state of balance, meaning gravity is strong enough to bend the planet's path into an orbit, but not so strong that it pulls the planet into the center, the planet moves around the Sun in a stable elliptical orbit. This state is called dynamic equilibrium, and it is what allows planets to maintain a stable distance from the Sun for billions of years without falling in or flying away from the solar system. If gravity were stronger or the planet's velocity weaker, the orbit would collapse, and the planet could fall into the Sun. Conversely, if the planet's speed were greater than necessary, it could escape the Sun's pull and drift off into space. 4. Kepler's laws, the golden rules describing planetary motion. The motion of planets around the Sun is accurately described by Kepler's 3 laws. The first law states that planets orbit the Sun in elliptical paths, not perfect circles, with the Sun located at one of the 2 foci. This explains why the distance between a planet and the Sun changes over time. The second law, the law of equal areas, states that a line connecting a planet to the Sun sweeps out equal areas in equal intervals of time. In other words, a planet moves faster when it is closer to the Sun and slower when it is farther away. The third law shows the relationship between a planet's orbital period and its average distance from the Sun. Specifically, the square of the orbital period is proportional to the cube of the average distance from the Sun. These 3 laws reveal that planetary motion is a stable, predictable system, not a random occurrence. They are the natural result of the interaction between gravitational force and the planet's initial velocities. 5. What happens if the balance breaks? Falling into the Sun or flying off into space. If, for any reason, the delicate balance between gravity and inertia is disrupted, the consequences would be clear and severe. For example, if a planet collides with another celestial object and its velocity decreases, the Sun's gravitational pull would become dominant, and the planet could spiral inward and fall into the Sun. On the other hand, if the planet's speed suddenly increases, perhaps due to a strong gravitational interaction with a massive comet, it could be flung out of its orbit. If it reaches escape velocity, it might even leave the solar system forever. This is why a planet's stable orbit is such a fragile and precious state in space. Fortunately, under current conditions, all planets are maintaining a stable state and are not significantly affected by external factors strong enough to disrupt their orbits. 6. Angular momentum and energy conservation. The physical laws that keep the system stable. Another important physical principle that prevents planets from falling into the Sun is the law of conservation of angular momentum. Angular momentum measures an object's rotational motion around a point, and in a system free from external torques, like outer space, it is conserved. This means that if a planet is orbiting the Sun with a certain speed and distance, it will continue in that orbit unless something alters its rotational force. Similarly, the law of conservation of energy states that the total mechanical energy of a planet, comprising kinetic energy, from its motion and gravitational potential energy, is also conserved along its orbit. These laws act like invisible guardians, ensuring that planets move in a steady, predictable path, neither falling into the Sun nor flying away into deep space. They are powerful evidence that the universe operates under precise and elegant scientific laws, astonishing in their complexity and consistency. In conclusion, the reason why the planets in the solar system don't fall into the Sun is not a coincidence, but the result of a harmonious interaction between several physical factors: the strong gravitational pull of the Sun, the initial inertial motion of the planets, the delicate balance between these 2 forces, and fundamental physical laws like Kepler's laws and the laws of conservation. It is precisely these seemingly invisible rules that have created a stable system lasting billions of years, where planets orbit the Sun like dancers who never miss a beat. Thanks to this stability, Earth, our home planet, can sustain life, develop civilizations, and propel humanity further into space. The story of planetary motion is not just a chapter in physics textbooks. It is a vivid testament to the wonders of nature and the brilliance of human intellect in unraveling the mysteries of the universe. Thank you for watching the video. Don't forget to subscribe to the channel and turn on notifications so you won't miss our latest and most exciting videos.